Hello, welcome. Thanks for coming. Great to see all of you. Appreciate kind of the flexibility here with the keynote, and I know we're like the last thing before lunch, so we'll try and get through this, but it should be pretty fun. We're the Texas Rangers, and we're going to be talking about our World Series success on the Data Intelligence Platform. As you may or may not know, we've kind of refactored a lot of our data strategy over the last couple of years, really pushing towards modernization, investing more in AI, and we won the World Series last year, which is crazy. So, yeah, hopefully. Of course, we're not going to claim credit. The athletes on the field, the players, the coaches, bringing that World Series home. But the way that we're using data to drive decision-making for the club in terms of making everybody better got us to where we are today. So just some quick introductions here. My name's Alexander Booth. I'm the Assistant Director of R&D. Been with the Rangers since 2018 and kind of really leading that new data architecture on Databricks and the cloud.
I'm Michael Topol. This is my 9th season in baseball working in analytics, but I just joined the Rangers last season, just in time for the World Series.
Same story for me. This is my second season now. Last year was my first year in sports as a whole, so my view is a little bit twisted here. But my name is Oliver Dykstra, and I'm a data engineer for the team.
Yeah, they like to say, like, before we hired them, we hadn't won a single World Series. Yeah, 5 years of me and nothing, but 1 year of these guys. There you go. Anyway, we're going to cover some things today. If you were here last year, we'll go quickly through some of the foundation setting, just kind of what is baseball, what's data in baseball, what are some of the big data that we're dealing with in our sport, and then we'll get into the good stuff, some of the data engineering that we had to do, some of the data governance that we had to implement the last year or so, and of course all the meat of the presentation, the AI-driven analytics, and then of course winning a World Series at the end.
So baseball's a long-standing sport, right? It's been around over 150 years, and statistics have always been a part of that. It's going way back to like the first box scores. Mr. Chadwick, coined the term strikeouts and putting the box scores in newspapers and things like that. We can. Keep me fast on these slides. I know we're limited here. So
I was like literally 100 years later. That's how long baseball's been around, by the way.
Yeah, and as it's evolved, it's been a really open source movement that has always started collecting baseball stats and through all of these different places. But there are also really targeted publications like Baseball Prospectus. Was a magazine that came out, publication, and started sending out these to front offices and things like that, and really got these statistics in front of decision makers and started to tune into new ways to evaluate players, right? Recent news, really amazing stuff. On the last slide you saw Retro Sheets was this really volunteer-driven army of people who had combed through newspapers to find 100-year-old newspapers, right? Micro files and all that stuff. Sometimes with conflicting reports of how games went, which I think is a data quality issue we can all relate to. But Seamheads here is another one of those kind of organization collecting old stats. And they built together an amazing collection of stats about what was known as the Negro Leagues. And just within the last, month, they merged those data sets together so to create new leaderboards. So, Babe Ruth is no longer the top career slugger. You've got the amazing Josh Gibson on top of that list. And it had the bonus of making all the worst people really angry. So, and of course, Moneyball. It became really popular culture and changed the way that other industries besides sports look at statistics and everything. But back then, these guys, first. So before it was batting average, and we found a new way to define this market inefficiency and evaluate players based on on-base percentage, which had a higher correlation to wins and all this stuff, and they were able to buy good players cheap.
The famous Billy Beane quote is get on base, we win. So this is why nobody cares about batting average anymore. You can see it, we're all kind of numbers people here. Correlation is way stronger in on-base percentage in scoring runs. So that's why we care about that statistic more than batting average. So
And yeah, Moneyball, it was wild time.
That was a good time. Yeah, the big idea here, though, is like Moneyball necessarily wasn't the catalyst in the front offices. All of these public open source researchers, sabermetricians were doing the work, and then the front offices popularized it. So that was like 20 years ago. So where has baseball gone in the 20 years since? Well, just more data, more tracking. Got a quick timeline here. So we started off with ball tracking in 2006. That's using a company called PitchFX that's going to be tracking your spin rates or velocities, where we're going to see more objective measures of performance. From there, in 2015 was the debut of StatCast. If you've ever watched a baseball game recently, you'll see things like, oh, brought to you by StatCast. So it's a pretty cool product. Essentially, it's a dozen or so cameras that are on every ballpark, and it's tracking everything, not necessarily just the ball anymore. We're now tracking the players, and we're now tracking pose tracking. We're tracking biomechanics now too, and weather data. So StatCast has really encompassed everything that could possibly be tracked at the ballpark. And that is owned and operated by Major League Baseball. So there's a little bit of nuance in things that we own and operate with our stadium versus what Major League Baseball owns and operates in our stadium too. But essentially all of this tracking and high frame rate data was really at the forefront of data analytics a couple of years ago, and we had to find a solution to get around that. But yeah, here's a quick, I promise you there's cameras. So if you've been to the Giants game yesterday or Monday or anything, look up. I promise you'll probably see a camera. The big black one behind home plate is a very common one. So again, these are just using radar and video to do that optical tracking of everything on the field. I forgot to mention, 2024 too, we had the new one of bat tracking, which I guess we'll talk about a little bit more later in the presentation.
Yeah, we just have a couple quick video examples now. As Booth mentioned, the StatCast systems are actually used. They're owned and operated by MLB actually, and then so all data is equally distributed to the teams from the standard StatCast systems, and then it's up to us to be process and analyze it. But there is a level playing field in data availability that we all get the same data. And MLB also then, like in this example, enhances their data product by incorporating the StatCast data into their broadcast and publishing it as well. So,
we're back. No, we're good. Yeah. So yeah, these numbers, the 436 and the 120 velocity, those are measured by kind of these camera systems installed at the stadiums.
Yeah, and then just one more example, so that was ball tracking, launch angle, exit velocity. Now we also have utilized the ball tracking and player tracking, and we can get real-time catch probabilities that are based on this tracking data and run through models. And that's stuff that we're going to use, but also that MLB can use for their broadcasts as well.
So there's like a public AI model that's like, all right, given how hard the ball was hit and where it's being hit in the stadium and how fast kind of this baseball player is and where they're oriented, 5% chance that he makes this play. So we'll go a little bit deeper into some of that AI-driven analytics later on in the presentation.
Yeah. Last one is just another example of this biomechanic data. This is not specifically Hawkeye, but a lot of it's going to be similar in that we're doing joint tracking. Different vendors do different methods for it. It can be literally hundreds of frames per second, and you're doing many, many body joints for all positions on the field. So pitcher, hitter, and then all the base runners, everything. And so this is just an example of what that data looks like and how we can translate it into more analysis.
Yeah, and this new data sources creates new KPIs. So for an example, there's a metric called deception, which is how long is the ball hidden behind the glove before it gets released. So if the batter has less time to view the ball coming at them, then they have less time to react, right? So we can now measure this using kind of the body. If I'm a bigger guy, I can hide the ball a little bit more when I go down the mound. It's very, very crazy where that's going.
So let's go.
Yeah, and then just the last one that Booth mentioned, relatively new weather sources, the data and other weather data, which is very specific. You can get it on a play level. So when we're trying to talk about what a probability of a home run was that the batter produced, you can now include, how much was that aided or hurt by the weather as well on that specific play. Yeah.
So yeah, more confidence in true talents, right? Like how many home runs did you hit at your stadium that were like actually only home runs because of the wind, right? And we play in a retractable roof, and it gets really hot in Texas. Yeah, I know that's what we all came to hear today. But that just means that like there's less wind, right? If we have the roof closed, so it can really impact how players could play at our own park.
Yeah.
It's not just data from MLB. Lots of people go to outside vendors, and we're seeing just an explosion of data sources from every angle, basically. I mean, you have it going through the minor leagues, which use different systems than MLB and give kind of a little bit different numbers, all the way down to college. And these days, even they have apps where parents can input play data about like their little league stuff. We're not quite collecting all the little league stuff yet, but throughout all of these sources, as well as international markets, we work to equalize and join all of this data together. So we kind of aim for 1 row per pitch, pitched anywhere in the world, more or less. So this influx of data, we started like anybody else on premises. And we could not handle all of this data coming our way. So during our first cloud migration, this is kind of where we ended up in our first attempt. And this is just one of our end products, the lineage and the flow to get there. And you have a big mess like that, and it creates a lot of problems, right? It was all time-based. So any misfires, and all of a sudden our stakeholders, our coaches and people aren't getting the data that they need when they want it, which is a big problem, right? And explaining why that is, not to mention, explaining how we came to the conclusions we came to with a system like that is pretty hard. So moving over to our new system, we are able to compartmentalize a lot more. We can drill down and say, okay, why exactly is this game missing, or why is that missing data? And from this idea of kind of taking the best in class where it's the most useful, right? So if we need to schedule an airflow, we do it there. If we can do it in Databricks, we do it there. And creating this overall unified data platform, right, to be able to mix and match as we need and bring in these data sources, whether it's biomechanics, pitch or weather, or scouting and medical data, and working it through our system and our medallion architecture to all of our end users and BI. Go ahead. It's amazing. Yeah. There's a lot of potential. Let's keep going. We're short on time. Let's keep getting to.
You got bat speed. That's a good one.
Yeah. So another problem with the old system, right? The time to ingest new data sources, new metrics was very slow, and this is a new one that came out really recently. Really cool stuff and way to evaluate players based on this data that we're collecting at different points of the bat, how fast they're moving, how they're twisting their body, and the whole thing, and what kind of bat speed they're generating.
At its slowest, it's 30 frames a second. At its highest, it's 300 frames a second of this like frame by frame like path of the bat. And then there's a lot of new like metrics and KPIs we can look at with the bat path. How does the attack angle actually impact like the exit velocity of the ball, or like the launch angle of the ball? And then how does that also couple with the biomechanics of the swing? How does the body look while you make that motion? Does that actually correlate or impact anything with the swing speed as well? And as you can see here, like there is going to be an observed impact. Ronald Acuna Jr. is really good at baseball. So is Seager and Simeon. But I guess I cherry-picked a couple of those guys on the chart.
And as I alluded to earlier, we believe here that baseball has always been an open source kind of project. And so we like to support open source as much as we can, and we really appreciate Databricks' partner ecosystem. These are a few of the partners that we've been really happy to partner with and have strengthened our data ecosystem.
Yeah. So getting some other problems that we had here, data governance. So it's not necessarily the most sexy thing in the world, but we ran into a lot of troubles with data governance. So quick thing, so we all work on the baseball operations side. So that's the front office, the Moneyball side of things, but we still have a lot of different departments that work together in this. So we kind of styled it as a hub and spoke model here. The amateur analytics guys looking at those little league players, I guess. The international analytics, player development looking at the minor league. Advanced scouting, we play the Dodgers again tonight. So yeah, don't look at the score from last night, but how can we try and win against the Dodgers? And of course, sports science, looking at the biomechanics on the field here. We need to have some kind of data sharing between that. We also don't want everybody to have access to all the records from all these other departments too. So trying to manage kind of those permissions was something we had to take pretty seriously. And of course, all operated with systems engineering and machine learning operations. So in case you didn't know, the Rangers are not just in Arlington or Dallas, Texas. We're a nationwide phenomenon. We have affiliates in North Carolina, in Texas. I guess that's about it. Dominican Republic. We used to have them a little bit more widespread. But Major League Baseball did a whole realignment of the minor league affiliates a couple years ago. So you can look that up on your own time. Not relevant here. And then of course the Dominican Republic. We have a complex in the DSL that plays in the DSL. So trying to get data from there too. And so with all of that, again, you have data analysts traveling with every single team, with every single affiliate. So being able to share and operate the correct data those guys are the mouthpieces, right? We can't travel with every single minor league affiliate on every single bus. So how can we make sure that the KPIs, the analytics-driven player development can be communicated well to whoever's going to be making those decisions? Sensitive information. So we do have to operate through regulations both by Major League Baseball as well as external. So FERPA, HIPAA, anything around education records. You've got the amateur draft coming up next month. We know their college transcripts and things. So that's something we have to be keeping super secure. Medical records, medical data. A lot of talk about Tommy Johns and trades falling through and signings falling through because of health. And then of course, addresses and contact information. I thought this is kind of funny. I actually found this on Hugging Face on like a training input data. Someone was asking the model for Corey Seager's residential address. I don't know why, but we want to make sure that's not leaked anywhere. So we do have some secure permissions wrapped around all of that as well. And of course, financials and contract information, understanding the escalators, how many home runs does Adolis Garcia need to hit to get an extra bonus. We don't want necessarily all of that leaking to the public as well. So of course we use Unity Catalog. We're very heavy in operating that between kind of our workspaces and our meta store, being able to use the fine-grained permissions on the columns, on kind of the role access. And also, as you'll see, we also do a lot of data sharing internally too. So while we do only operate on the baseball side, there's still a lot of collaboration with the business and the fan engagement side. And we can share that data across workspaces and concessions using Delta sharing. So I got a quick case study on this. This is my the Glizzy model. So Glizzy's is hot dogs, by the way. So this was a very public thing that the New York Mets did a couple months ago. They had their first ever dollar hot dog night in a long time. We have a dollar hot dog night every month, basically. And we've had them for years and years. But apparently it's a big deal for the Mets. So in front of the $1 Wiener Boys, Steve Gelbs in a hot dog suit reported that the Mets ordered 70,000 hot dogs. However, they only sold 45,000, and only sold is in quotes because that's a lot of hot dogs. I feel on average, I think that's 2.5 hot dogs a person here. But anyway, I think there's a little bit of inventory mismanagement there. Why are you ordering 70,000 hot dogs when you only have 22,000 people showing up and you're only going to be selling 45,000? So using data collaboration, using data sharing, maybe at the Rangers we do something similar to this, but knowing the expected runs, knowing who's pitching, knowing and better understanding of predicted attendance could actually help you predict how many hot dogs are going to sell to optimize kind of that inventory a little bit better. So we do collaborate with the business side, make sure that they say, hey, Nathan Eovaldi's starting tonight. So we expect, and we're playing the Dodgers, and that's gonna be a big bump in attendance. So we're probably gonna sell more hot dogs tonight. So again, not as glamorous as signing Corey Seager, but still a real interesting application of that data sharing and that governance across workspaces.
It's me.
All you.
Okay. Yeah, so just going to the area talking about what parts of baseball operations really do analytics impact, and it's pretty much everything. So from a high level, we can say this is what acquiring players. You can talk about through the draft that's coming up. You can talk about trades, signing free agents, and then once you've acquired these players, you want to make them better. So this is working with player development. A lot of the data that we've been talking about, with whether it's biomechanics, the swing data, pitch optimization, that's all. So you acquire the players, and then once you have them, you make them better. And then once you make them better, you try to win as many games as you can with them. And that shows up as an in-game strategy. It can be things like lineup optimization. It can be matchups. Just a lot of ways that we support. And really, like all three of these areas, most of the stakeholders that are actually implementing the work, whether it's the players, the decision makers, the coaches, are not technical people. So it's our job as analysts to get the data that's imported and then get it to them in ways that are useful and that they can, and it's become such a big part of the game over the last 10 whatever years that they really, like most of the coaches and even the players at this point they don't just, it's not you forcing it to them, they really want it and they use it to get better. The first example being the launch angle revolution, which basically just the reference to the extreme optimization towards hitting the ball in the air and getting home runs over the last few years. And it would be pretty arrogant for like nerds like us to say that we discovered home runs are valuable, but because those have been like obviously a huge part of the game of baseball for over 100 years now. But through a various, like just this evolution of analytics, things that we might talk about like linear weights, we get to say back exactly how, a more precise valuation of how valuable they are. And then we talk about expected home runs using things like the launch angle and the exit velocity. And now even with this new data, we're beyond just how valuable they are. We can use the biomechanic data, the bat tracking, and just get a lot better at projecting how, and so we can evaluate players better on how likely they are to get these valuable hits, but we can also work with the coaches and stuff. So it's not just evaluating, it's also improving the players that we have and working on getting them better at doing that.
And some of this stuff like has impacts like other sports as well. So I also follow a little bit of cricket. So I don't know if you follow any of the T20 stuff going on right now. But USA Canada game 1, so not the Pakistan game. Game 1, USA Canada, basically you had to get, it's called the chase. They had to score like 193 runs, right? It was crazy. Like there's no way they were gonna do it. So what they ended up doing though was just hitting a whole bunch of like cricket home runs. The guy was just launching sixes. It was nuts. And so they say like you see this in other sports too. With T20, you have a set amount of balls, so you have to have a set amount of time to be able to score as many runs as possible. So now trying to hit more and more, I guess, aggressive run scoring using launch angle revolution is really interesting. So you see this a lot in other modern sports too, trying to use data to optimize kind of the run scoring potential of a given situation.
Yeah, and it's not just hitting. Like we're gonna go through pretty much any area, and the other main part of baseball is pitching. And if anything, hitting has probably been trying to catch up to pitching in terms of the analytics revolution. This here is just an example from a publicly available pitch grade model that's called Pitching Bot that's hosted on Fangraphs now. But pretty much any major league team has its own internal version of this. And on the right is basically a flow chart of potential outcomes of a pitch, whether they swing or not, and if they do swing, what type of, if they'll make contact, and if they do make contact, how good of contact will it be? And each node along that chain, you can imagine just being its own machine learning model. And then it's our job to aggregate all the tracking data we've talked about, and then we can get better evaluations of how the quality of a given pitch beyond just the outcome. There's a lot of randomness in baseball, so generating models like this allows us to strip out some of this. Like, for example, like maybe a pitcher throws a bad pitch, but the hitter doesn't happen to swing at that one. But we think that typically if a major league hitter did swing at it, he would have done good damage. So in that case, he might have gotten lucky. He wasn't facing a good hitter, but overall we still know that that was not necessarily a good pitch. And so when we're talking about predicting future outcomes, using stuff like this is going to be a lot more predictive than just looking at actual outcomes typically. And beyond predictions, also, again, I'll just reiterate every time, it's like also being used for, like, it's not just teams, like they go to driveline, it's used for development, and this is players are really optimizing how they play the game based with feedback from these. This is just another, we don't have to spend too much time on this, another example. These are all hosted, these are public again, this is on Savant, but it's a stolen base probability. I guess one like interesting thing, like we're basically just modeling the events of baseball, and when you're doing this, you can really flip it on either end to evaluate players. You can evaluate, depending on what you want to control for, you can evaluate a catcher, how well did he do to prevent a stolen base, or you can evaluate a runner and say how well did he do in order to steal the base. A lot of the components I think are shown up there of like what goes into being able to steal. It's like starting distance of the runner from the bag, how fast they are, the pop time, which is basically how fast the catcher can get the ball to second base to stop the steal. So all these things, like depending on who you're trying to evaluate, sometimes if you're trying to evaluate a catcher, you're not gonna put information of the catcher into the model because that's what you're trying to control for. But if you're trying to evaluate the runner, then you might put information about the catcher. So we have like a lot of various like forms of kind of modeling the same event depending on what the use case is.
Yeah, and like one last big idea here too, like these last three models, they're not just reactive. We're not just evaluating what the player did. We're trying to also make it a little bit more prescriptive or predictive. So like when should we encourage a base runner to steal using kind of this model? How can we make our hitters better given a launch angle? How can we make our players better given these machine learning pitching models, right? So it's all kind of tied together in both of those perspectives.
And this is just showing the starting position. So it's basically looking at positioning versus different types of hitters by handedness. And any team now can utilize all the ball tracking data, all the positioning data. We know where everyone's standing, and then combine that with like our hit probability models. Basically, each team will have their own optimization algorithm, but we're all pretty much trying to position to get the most outs in the simplest way. This is one area that we got so good at basically that the league banned it last year. Not completely because but they did put a lot more restrictions in because our job is to optimize to win the games. Theirs is to optimize to make the games better to view. So now we have more constraints, but we still have the models. They just have some new constraints in them.
Yeah, and these graphs are from 2024. So you can still see that we are still doing an AI-powered defensive positioning recommendation for various situations during each game. So keep an eye out, like next time you're watching a game too, look at the defense. Even at like 2 strikes, people are gonna like move around. With every batter that comes up, everybody kind of moves and shifts around. All of that is AI driven.
Finally, just like one other aspect of the game that like before didn't really show up on baseball cards or anything, but talking about defense and using this ball tracking and this player tracking throughout the play, we're able to generate things such as catch probabilities. And these are really useful in terms of evaluating defenders, and we can aggregate them into things like outs above average that turn into components of WAR, which is our like overall evaluation. Well, we're going into the projections next, so I assume most people here probably WAR is wins above replacement, which is how we if we like try to wrap everything into like one number maybe of valuing a player.
Yeah, a lot of it's like all stacked. It all builds and stacks on each other. Like even with the hot dog model, you predict attendance and then predict hot dogs. For the pitching model, you predict the probability of a strike and then you kind of build off of that. So we're kind of just building everything together, stacking these models, connecting these models together to create continuous, I guess, final metrics, which I guess, leads well into projections.
Yeah, so basically, again, this is just a public version of something pretty much every team will have. This ZIPS projection hosted by Fangraphs. All these things that we've been talking, you could build one without any machine learning if you wanted to, but it's gonna be a lot better once you start incorporating all these various metrics that we've talked about, whether it was the expected home runs, whether it was the pitch grades, whether it was for defense, and we're talking about catch probabilities. All of that is gonna improve our projections, which ultimately is one of the biggest products as a R&D department that we're trying to get, is this one number of a value of how we project. Those are all talking about how they performed in the past. Now we have to tell our decision makers know how they're going to perform in the future.
That goes by that communication too. Like, do you think people really want to hear about like, oh, the R squared or the F1 score of this model? This guy's so good based on this like probability. No, they want to. How many home runs is Adolis Garcia going to hit next year, right? Like, how many home runs is this pitcher going to hit or give up? Like, that's going to help me make my decision as a baseball guy a lot more efficiently. So, how can we connect a lot of that communication back to the AI underpinning kind of the analytics itself too? So projections are a great way to kind of help bridge that communication gap. And of course, we're doing some GenAI. I got a couple slides here on kind of where we're going kind of with LLMs and how they can help us in baseball as well as with some fan engagement side too. So beyond Copilots, obviously we use Databricks Assistant, GitHub Copilot, all that fun stuff. But we've actually started messing around with Databricks Genie, which you'll see a demo of tomorrow in the keynote too. Essentially, it's a natural language interface into our tabular data. So again, we talked a lot about communication. We have a lot of people, a lot of our executives, they ask, who is good on the Cardinals? And we go, what? And so we go back and forth and try to make a report, update queries, give them back to them, right? And then we missed out on a column that the guy wanted. So we have to go back and rewrite the query. So how can we just give these guys a little bit more power to query the data themselves to try and find players? There's thousands and thousands of players in baseball. How do you find the guys that you think may impact the game in a trade later on in the season? So in this case here, I'm using natural language to query, create a quick leaderboard and say, hey, Corey Seager is somewhat good at baseball. Pretty good at baseball. So we got some other ones to go going. There's a lot of text data in baseball too. So think about all of the newspapers, the news articles, the tweets. If you have a beat reporter, a favorite beat reporter that writes about your team, there's a lot of text information in that. There's also a lot of text information in kind of the fantasy bios or like the expectations for the next game or even in scouting reports, right? So being able to summarize, look at sentiment, be able to query some of that information a little bit more effectively is a great skill to have. So being able to implement some open source models here, we have experimented with RAG. We've created some internal RAG chatbots around a lot of these internal kind of text objects to again allow and facilitate people to query, summarize, and not necessarily have to read dozens and dozens of blog posts about how good Corey Seager is. So it's been a really powerful tool that we're still trying to work on hitting production. Again, a lot of the discussions you heard in the keynote, we run into a lot of those same barriers too. But we do have some production generative AI features. So this one's on the fan engagement side. It's an activation that you'll see during the game. So you go look up in the third inning. I guess you got to start in the first inning. Then put a little QR code up. You got to take a selfie of yourself and then upload it to this QR code. And then we have a prompt. So every night it's different. So this example, photo cred me, by the way. But this prompt here, Lego minifigure. So we take that selfie that the fan took, we run it through a generative image model like Midjourney, Stable Diffusion, and we end up with kind of the output here that we then show side by side on the scoreboard. So this got a lot of fun reactions from the fans. We kind of had a little hesitancy when we first kind of rolled this out at the start of the season, but the fans love it. So we start going a little bit more crazy, like Pixar baseball player on the moon, space cowboys or desert cowboy. There's some really crazy ones that we've been doing lately. And we do have some manual kind of filtering here to make sure the images look good before we put them on the scoreboard. And you know how quick kind of the half innings go. So we only show maybe like a dozen of these. But it's still a really cool activation. And we are actively looking at other ways to generate more engagement using GenAI, whether it's can I bring in a bag, or how big does my bag have to be to get into the Oracle Park, or can I bring in a water bottle or flavored water, right? Like there's so many nuances now in attending these events or concerts or wherever, right? So being able to just interface natural language into that should hopefully make that more efficient. Of course, wrapping it all home here. Where did this let us? We're quoting our own senior director of R&D here, who may be in the room. You can hunt him down afterward. But we do really like this quote. It's one of our core tenets in analytics. If you can make yourself 0.5% better, whether that's in terms of literally probability or whether it's in terms of just hitting the baseball better or throwing a little bit faster, it can be the difference between making the playoffs and not making the playoffs. We barely made the playoffs last year. It was like we lost the last game of the season. It was very heartbreaking. I remember where I was. It was sad. Right?
we clinched it the second to last game of the.
Yeah, something like that. Which one do I? We barely made it. We made it as a wild card. And then using kind of all of these analytics, we have reports where we kind of visualize things. There are some examples of our game reports that we're showing our players. So you can see that this is what our players and coaches are receiving before and after every game, just about kind of their work. We had a quick video here on Josh Young. I will play it. It'll be quick, though.
Exit velocity is the really cool thing, but I don't really focus on that a whole lot until like towards the end of the session after I get all my field goal stuff in. But I'm really looking at launch angle because without that, I mean, that's just a result of, to me, it's a result of my thought process when I'm swinging, when I'm in the box. It's not really anything more than that because you can get lost in that really quick and people can literally start swinging up. But for me, I look at that just to make sure I'm within the right range. I think especially in professional baseball, I have a thing called barrel percentage, and that's hitting the ball between 25 and 35 degrees. With the Rangers, we say 20 to 35 degrees is the...
So as soon as he said that, so what he just said there was that publicly, the barrels are like 25 to 35, but at the Texas Rangers, it's 20. That's why I'm like, okay, so all the teams now are going to be looking at 20 degrees. And that's also why we could put that on the slide of our little... I think we did 25 to 35 on that one, but it shows kind of the impact of this. Josh Young, a professional baseball player, he's using these models that are recommending these launch angles to be better as a player. And that's what he was working on in the batting cages with the coaches. And it's all coming from all the work these amazing guys up here are doing. So just to wrap it up, obviously we won the World Series last year, going an unprecedented 11-0 on the road. It was insane, crazy run. All the credit must go to the players and the coaches, but I like to think that some of our work helped a little bit along the way. Typically, we like to look at the defense. There's a lot of crazy stellar catches, a lot of double plays that came in clutch, and a lot of that was because of the defensive positioning work that a lot of the guys up here kind of helped us put together, and that really came home in the Arizona series. A lot of good double plays in there. And of course, here's our photo on the field and our photo with our rings and things. So hey, we won a World Series too, pretty cool.
And of course, we couldn't have done it without Databricks, our enablement team, Chris and Hussein. I mean, if we could have gotten you rings, we would have, but...
Yeah. Anyway, we have one last payoff slide here. We have 4 times more data coming in with these high frame rate technologies at a much lower cost than what we're trying to do with our on-prem and other kind of legacy stacks. We have over 300 users around the world, again, scouts, players across all of our affiliates, data analysts at all of our affiliates, accessing and utilizing kind of data and democratized data, all kind of managed through Unity Catalog with secure governance. 10 times faster speed to insight. So again, instead of having to wait a day or two to make a report for a player, we can give them right after the game or right before the game. We're really quick to be able to turn around these live reports than we used to be. And of course, culminating in our first ever World Series championship. So I think we're just getting started. Looking forward to kind of the next go around. And I think I got 12 o'clock, so I don't think we're taking questions, but we do have a very fun montage video you can walk out to.
Happy to talk with any of you outside.
Have a
good day, everybody.
I appreciate you all.
Thanks so much.